Hi there, folks. We're looking at simplifying and solving equations here, just some of the more complicated equations. So remember, when you're solving an equation, you're working backwards to order of operations, and you undo the operations as you go. But sometimes we have to simplify some stuff before we start working backwards, okay? We simplify by doing things like our distributive property and combining like terms, and then we solve the equation. Okay, so let's look at a couple of these where we're simplifying, distributing, combining like terms, that kind of stuff, and then solve the equation. For example, if I look at something like this guy. So right away, instead of trying to go right to solving this thing, because it's hard to undo this stuff, because all these pieces are scattered all over the place, we want to condense it, we want to simplify it first, and then we will solve. So I'm going to simplify by using my distributive property. Remember the distributive property, you just give that multiplication way to each thing. So 4 times 2, 4 times 5. And then everything else we just kind of write down. And now we combine like terms. I have like terms over there. I've got an 8x and a minus 4x. 8x minus 4x is a 4x. So I can actually combine these guys together. So these guys get added together. And now we're back to the type of equation that we can start working backwards to order of operations. I undo addition and subtraction first. So to undo this plus 20, I'm going to subtract 20. Make sure you do it to both sides. The plus 20 and the minus 20 cancel each other out. And now I undo multiplication using division. So to undo multiplying by 4, I divide by 4. Again, make sure you do that to each side. And once again, the multiplication and division cancel each other out. I get x equals a 3. Okay. If I look at the next one, same kind of thing. Distribute. Let's combine like terms. So I distribute. I'm going to distribute the 3. I also have to distribute this guy. Notice, make sure you include that minus sign. You have to distribute that negative sign. So it's like a negative 4 being distributed. Always include the sign. And so as I distribute this thing, that's a 3x plus 15. I just multiply each of those. And then over here, negative 4 times x is a negative 4x. Negative 4 times 1 is a negative 4. And now combine like terms. Look for things that are the same. So right here, these x's are the same. So 3x minus 4x is a negative 1x. These guys, the plus 15 and the minus 4, they can be put together. So 15 minus 4 is an 11. And now I can continue to solve this thing. Now I can undo the operations and work backwards to order of operations. So here, I undo the addition by subtracting. Again, the plus 12 and the minus 12 cancel out. That is a negative 14. And now this is a multiplication question, really. There's a 1 out front. We didn't write the 1 before, but it's a negative 1x. So to undo multiplying by negative 1, I have to divide each side by negative 1. And of course, the multiplication and division cancel each other out. Over here, I get a positive 14. Okay, so simplify and then solve. Use the distributive property, combine like terms, and then start working backwards to order of operations and undo those operations as we go. Okay? We might also have variables on both sides, and this is another way that we have to simplify before we can solve. See, we can't go right to undoing the operations until we get the variables together. And if I have variables on two different sides, I need to get rid of one of those. Okay? I can't have the variables split up like that. Okay? And so to get the variables on the same side, I just get rid of them from one side. So if I look at this example, I've got a minus 8x on one side and a plus 4x on the other side. It's no good to have those split up, okay? So I need to get rid of one of those. I either need to get rid of the 4x by subtracting 4x, or I need to get rid of the minus 8x by adding 8x. Okay? And so what I always do is I always look at the smaller one. I always get rid of the thing that's smaller because it's the easier one typically to get rid of. It's the easier thing to move, all right? And so between a negative 8x and a positive 4x, the negative 8x is smaller. So I say, you know what? Let's get rid of that negative 8x, and I do that by adding 8x, okay? That's what will make this thing cancel. I just have to make sure I do that to both sides, okay? So here, the minus 8x and the plus 8x cancel each other out. So I'm just left with a 7. Over on this side, this is really just combining like terms. The 4x and the 8x together give me a 12x. And then the minus 17 kind of tags along for the ride. Now that I have the variables together, now that I don't have variables on both sides, all right, I've got the variable in one place, now I can work backwards through order of operations and solve and undo the operations as we go. So let's undo subtraction first. To undo this subtraction, I'm going to add 17. And again, the plus 17 and minus 17 cancel out. Over here, that's going to give me a 24. And now I undo multiplication by division, so I divide each side by 12. So I get x equals a 2, and I'm going to rewrite it like this, x equals 2. Okay? But again, it's simplify and then solve. If I look at the next one, I want to simplify and then solve. The first thing hopefully I notice is that I have my distributive property there, so I'm going to do my distributive property. And remember, a 1/4 is just a divided by 4. That's what a fraction means. It means division. So a 1/4 is just divided by 4. So as we distribute that thing, 16 divided by 4 is a 4, so it's a 4x. 60 divided by 4 is a 15. Okay, and that's what you get when you multiply by 1/4. It's just dividing by 4. Okay, so now I simplified using my distributive property. I have variables on two different sides. I don't like that. I can't have them split up like that. So I look at the 9x and the 4x. I'm going to get rid of the smaller one. The 4x is smaller. So to get rid of a 4x, I'm going to subtract 4x. Okay? Again, think of it as getting rid of that thing. That helps us remember that we want to subtract or add depending on whether it's positive or negative. I have to do that to both sides. Over here, those cancel. I've gotten rid of the x on that side, which is kind of what I was trying to do. So I'm just left with 15. Over on the other side, we're just combining these like terms. The 9x minus 4x is a 5x. And then the minus 5 tags along for the ride. Now that I've simplified, I simplified using my distributive property. I got the variables in one spot. Now I can solve this thing by working backwards through order of operations. So I'm going to undo the subtraction first by adding 5 to each side. So the plus 5 and minus 5 cancel out. And now I can undo that multiplication by division. And there it is. Okay? And again, I didn't show it in either of these, but the times 12 and divided by 12 cancel out. The times 5 and divided by 5 cancel out. That's why we're doing what we're doing. Okay? If I look at this one, again, let's use that distributive property first. So let's use our distributive property. I'm going to distribute the 2. On the other side, I'm going to distribute this 3. And again, the distributive property is just multiplication. 2 times x is a 2x. 2 times 3 is a 6. Over here, 3 times x is a 3x. 3 times 2 is a 6. And then also have this minus x. And then notice some of my variables are on the same side. The 3x and the minus x are already together. So I can combine those. I'm just combining like terms. I can add these together because they're already on the same side. Oops, sorry, I switched colors there. Now I want to get rid of the variables for one side. These are both the same, the 2x. So to get rid of one of those, let's say I'm getting rid of the one over here, I'm just going to subtract 2x. That's how I get rid of it. But then I have to do the same thing to the other side. And what happens is 2x and a minus 2x cancel out. But on the other side, 2x and a minus 2x also cancel out. So I'm left with a 6 over here, and I'm left with a 6 over here. And this is one of those special situations where we get a true statement. If all the variables go away and I get something like 6 equals 6, remember this is the special case where the answer is all real numbers. Okay? The answer, x, could potentially be anything. Okay? And that's what this means. It means that we just have a situation that no matter what I plug in for x, it's going to work. Okay? If the other side of this, the kind of the flip side of this coin, if I get something that's not true, like here I got 6 equals 6, that's true. If I got something that's not true, like 6 equals 5, well then I would say no solution. Because what that's telling me is that no matter what I plug in for x, it's not going to work. Okay? So keep in mind those are the two special situations when the variables are gone. A true statement is all real numbers. A false statement, something that's not true, is no solution. Okay? If I look at the next one, again, my distributive property, I'm going to distribute this 2. On the other side, I can distribute that 3. So I do my distributive property. Again, 2 times x is 2x. 2 times 4 is an 8. The other types, 3 times x is a 3x. 3 times a negative 1 is a negative 3, so minus 3. But now as I look at this, some of my x's are already on the same side. The 2x and the minus 4x are already together. They're already on the same side, so I just have to combine those. They can just be added together. So I combine those like terms. That's a negative 2x and the plus 8. And so I simplify by doing my distributive property. I simplify by combining like terms. And now I want to simplify by making sure I only have x on one side. See, I have x in 2 different places now, 2 different sides. That's no good. So I'm going to get rid of the minus 2x because it's smaller. That's just the way I always do it. And to get rid of a minus 2x, I'm going to do a plus 2x. Whatever I do to one side, I have to do to the other side. And so again, these cancel. I got rid of x over here, which is kind of what I was trying to do. And now over here, I have to combine the like terms. That's a 5x and a minus 3. And now I can work backwards sort of operations. Everything we've done so far is not really the process of solving. It's the process of simplifying. Now I can solve by working backwards. I undo subtraction by addition, so I'm going to add the 3 to each side. And again, the plus 3 and minus 3 cancel out. And now I undo the multiplication by division. So I get x equals, and once again, the times 5 and divided by 5 cancel out. 11 divided by 5 is a 2.5, so we can leave it that way, and that'll be fine. 2.5. Okay. Oh, sorry, 2.2. Sorry about that. So 2.2. Okay, and you can just use your calculator for that. If you want to leave it as 11 over 5, you could. You could also write it as 2 1/5 would be okay. Okay. The last piece of simplifying and then solving is getting rid of fractions. Okay, fractions are something that students are very scared of when we see these. We get really worked up. We're not comfortable dealing with fractions. But the easiest operation to perform when you're dealing with fractions is multiplication. And the reason that's the easiest is because fractions are just division, all right? And division and multiplication cancel each other out, all right? So we want to do multiplication here to get rid of fractions, and we do that by multiplying through by the common denominator. We don't get common denominators. We don't get common denominators for these fractions. We get rid of the fractions by multiplying by whatever the common denominator happens to be. Really, we're just multiplying by the least common multiple. And all we're doing there is we're undoing a bunch of division at the same time, okay? We're finding a number that undoes, for this first example, we're finding a number that undoes dividing by 2, but also undoes dividing by 4, okay? So when I look at this, between a 2 and a 4, the common denominator is a 4, okay? It's a number that each of those could be multiplied by something to become, all right? And so here, I'm just going to multiply each side by 4. And see, 4 is a great number here because times 4 will cancel out a divided by 2. Okay, but times 4 will also cancel out a divided by 4. See, it's just a bunch of divisions, and I want to cancel out all of them, okay? So here I distribute this thing, and as I distribute, really, times 4 and divided by 2, that's, remember, what a 1/2 is. 4 divided by 2 is a 2, so that gives me a 2x. The next one right here, the times 4 and divided by 4 cancel out, so I'm just left with a 3. And if you really need to take that off to the side and do it on a calculator or something like that, that's fine. But again, 4 times 1/2, really that's just divided by 2, and that's where I get the 2. Same thing here, when I do 4 times a negative 3/4, well, the times 4 and divided by 4 cancel out, okay? But keep in mind, we also have to do the same thing to this other side. So over here, I have to do the times 4 as well. So that's a negative 12. All right? Just like any time we're dealing with any other equation, whatever I do to one side, I have to do to the other side. But what happens here is once those fractions go away, this is a much easier equation to solve. So to get rid of the minus 3, I'm going to add 3 to each side. That cancels, so I'm left with a 2x. And now to undo the times 2, I divide each side by 2. And once again, you could just plug this into your calculator and do a negative 4.5. Okay? If I look at the next one, once again, I've got a 3, a 4, and a 12. So I need a number. I need to multiply by a number that all of those things can divide into. In other words, I want to multiply by something that's divisible by 3, but that's also divisible by 4, but that's also divisible by 12, okay? And so the number that I'm looking for is a 12. It's what the common denominator would be. So I'm going to multiply each side by 12, okay? This is how I get rid of fractions. And 12 is not the only value. I could multiply each side by 24, and that would work because 24 is divisible by 3, it's divisible by 4, and it's divisible by 12, okay? So we just need to multiply by something that's going to cancel out all of those divisions, okay? And so here, as I distribute this thing, again, that first one, that just says divided by 3. So 12 divided by 3 is a 4, so I get a 4x, okay? The next one, that really just says the 1/4 is just saying divided by 4. So 12 divided by 4 is a 3. And then over on the other side, 12 divided by 12, see, the divided by 12 and the times 12 cancel each other out, so I'm just left with 17. Okay? And if you need to, take it off to the side, write each of those fractions, each of those multiplications, and then work through it. It's times this divided by this. Okay? Now this thing is much simpler. Now I can work backwards through order of operations and solve this thing. To undo adding 3, I subtract 3. Cancels this, so I'm left with a 4x. And now to undo multiplying by 4, I divide by 4. And so that's a 3.5. Okay? So again, simplify and then solve, okay? We simplify by doing our distributive property. We simplify by combining like terms. Then we simplify by getting the variables in one place. So if I have variables on both sides, I get rid of one of them. I simplify by getting rid of fractions. And after doing all of those things, after simplifying, we're left with typically an equation that's much easier to solve. So then we work backwards through order of operations. Then we undo the operations as we go. Okay?